Hey guys, we're going to take up Unit 4, Handout 5B, number 2. It's an open delta question here. The only information you have is that the phase voltage on the secondary side is 208 and that the load is Y connected and it's 4 ohms. Notice that it doesn't have a ratio here, and that doesn't matter because it's not going to ask us any questions about the primary anyway. And so, this thing's got a bunch of questions here that we're supposed to work out here, but it doesn't matter. I'm going to actually try to figure out everything that's going on with the secondary side of this transformer here. And then once I got it all figured out, I'll go down here and see what else I need to figure out here. So, open delta, it's the same as closed delta, right? E phase is equal to E line. So it says here E phase secondary is 208 volts, and that voltage would be from here to here, right? And let's figure out E line secondary because I'm going to need it, okay? Because that's the only way to figure out the phase voltage at the load is to know, one step at a time from phase to line to phase. I'm going to just turn off, there we go. Okay, and so E line secondary, and this is open delta, so it's delta, which means that E line is equal to E phase. So this is 208 volts from there to there, and then right here, guys, this would be E phase load. Okay, and it's a Y connected load, and so that 208 volts is going to drop part of it on there and part of it on there, right? And so E phase load. I'll do it right here. E phase load, it's going to be E line divided by root 3, okay? And that's because I know this voltage is going to be less than 208. That voltage plus that voltage equals 208. And so it is the 208 divided by root 3, and so it's 120 volts, okay? If you do 208 divided by root 3, 120 volts right there. So the next thing I'm going to figure out is I phase load. Okay, and that would be the current. I'm going to switch. That would be this current right here. Right? And I phase load, it's going to be the 120 divided by 4. So it's going to be, it's Ohm's law. 120 divided by 4. And so let's do that for a second here. Can you guys see this? 120 divided by 4. 30 volts. Okay, so this guy here, no, 30 amps. Okay, this is current we're talking about here. 30 amps. And while we're at it here, I'm going to calculate I line secondary, which will be this current right here. Now, this is Y, so that current will be the same as this current, right? So I line secondary is going to be 30 amps. 30 amps, okay? And I'm also going to calculate I phase secondary, and this thing is Y, open delta. So if this is 30 amps, then this has to be 30 amps, right? Because that's how open delta works. So this is going to be 30 amps as well. Okay, so now I have, all the voltages and all the currents on the secondary side. I don't know anything about the primary side. I don't know the ratio, but it doesn't matter. So let's see if we can figure out, if we've answered any of these questions here. Let's start with A here. What is the phase voltage at the load? Okay, so that's E phase load. It's 120 volts. Okay, so we'll check that out. Yeah, that's what I had for homework here. It says calculate the line current to the load for the circuit above. B. That should be 30 amps. Okay, I'm going to slide this up a bit. Okay, what is the phase current in the secondary windings of the open delta transformer? C, 30 amps. Okay. D, calculate the kVA of the open delta transformer. Well, to calculate the kVA of an open delta transformer, the VA is equal to E phase times I phase times 2. Okay, you're calculating the kVA of one of these, the voltage times the current, times 2, because there are 2. And so E phase for that secondary We decided it's 30 amps. Nope, sorry, we decided it's 208. I phase is 30 times 2, and we'll calculate that. So it's 208 times 30 times 2. 12480. Volt amps. Okay, that is the kVA of this open delta transformer. There, I've got it. 12.48 kVA. Okay, calculate the kVA of each of the two transformers that make up the open delta transformer. Now, when I say two transformers, you know, you've got two primary, a primary and a secondary, and another primary and a secondary. So there's one transformer, there's the other transformer. That's the two single-phase transformers that are making up this open delta transformer system, and it wants to know the kVA of each of them. Okay, well, there's two ways to do it. You can divide this in half, because this is the VA of the whole thing, and it's made up of two. So, you know, I could just take this 12,480 and divide it by 2, or I can calculate the VA of one of the windings, and the VA of one of the windings is going to be E phase times I phase. Okay, and so it's 208 times 30, and it's going to end up being half of that, right? Because we're not doing the times 2. And so 208 times 30 equals 6240 VA. Why am I making you calculate that? Well, if you're installing this open delta transformer system, you know, there's a good chance that you're going to be taking two single-phase transformers to build it. And so, you know, what size transformers do I have to buy? You need to buy two of these, okay, in order to make this 12480 VA open delta system. Okay, you're going to buy two actual transformers this size. Let's see what F is, guys. Calculate the kVA of a three-phase closed delta transformer to feed the same load. So how am I going to calculate the kVA of a regular closed delta transformer to feed this load? Well, the easiest way to do it is to forget about this transformer. Just calculate the kVA of this load, and if you know the kVA of this load, you will know what size transformer you need to feed that load. And so the way I'm going to do F is I'm going to go E line secondary times I line secondary times root 3. Okay, that is the current feeding this load times the voltage feeding this load times root 3, because it's a three-phase load. I could also go E phase, I phase times 3 for this load. That would also work, but this is the one I'm going to do. So it's going to be 208, which is the line current feeding the load, times 30. Sorry, 208 is the line voltage feeding the load. 30 is the line current feeding the load, times root 3. Excuse me, and I know I'm going fast, but watch the video again, or slow it down, or rewind it, okay? Basically what I'm doing is I'm just calculating the VA of the load using E line, I line, root 3. Same way we have been. Comes to 10808 volt amps, okay, or 10.8 kVA, and there it is, okay. Last one. Calculate the kVA of each of the three transformers that make up a closed delta system. In other words, if this was closed delta and you were building this three-phase transformer out of three single-phase transformers, you know, how big would they have to be so that you can order 3 of them? And there are multiple ways to do this as well. You can calculate the VA. Well, guys, the easiest way is to just take this number and divide it by 3, okay? Because this is going to be all 3 or the whole three-phase transformer. So in order to calculate it, G here, I'm just going to go 10808 divided by the 3 transformers that you would require to build the closed delta system. So divided by 3 equals 2603 VA each. Okay, and that's what I got here, 3.6 kVA. Whoops, I made a typo here. This is 3603. 3603. Okay, which is 1/3 of this. All right, so I hope this helps. Let me know if it doesn't. Basically what I did was I didn't worry about what was asked here. I figured out the voltage all the way to the load. I calculated the current at the load. I figured all my currents back based on all the rules for three-phase and also the rules for open delta. And then after I had all that figured out, I came down here and started answering the questions. I had figured most of it out already. The only thing I hadn't figured out is the kVA of the transformer. Well, the kVA of an open delta transformer is E phase times I phase times 2. To calculate the kVA of the two transformers, I just divide this by 2. Or it's E phase times I phase. To calculate the kVA of the system if the transformer was closed delta, I just calculated the kVA of the load. I used E line times I line times √3. Whatever the load kVA is, that's how big the closed delta transformer would be also. To calculate the kVA of each of the 3 single-phase transformers that make up a closed delta transformer, I divided this number by 3. Since this is all 3, each one would be 1/3 that size. Have a great day.